And welcome you all to this session on this Lean Six Sigma Yellow Belt. So first of all, I would like to thank all of you for joining this session. And I hope that all of you will have a wonderful learning experience. So since I think many people are there, maybe I don't think you'll have time to introduce all of you. So I'll just give a small introduction about myself, and then we can get started. So my name is Annamalai. I am basically a BTech engineer from IIT Varanasi, and I passed out in the year 1985. And I was in employment for almost 30 years, working for both the manufacturing industry and the IT service industry, both in the production function and quality function. So I was certified as a Lean Six Sigma Black Belt in the year 2004, and I was certified as a Lean Six Sigma Master Black by Indian Statistical Institute, Chennai, in the year 2013. And I have been running this company, ICEQBS, for the last 10 years. And we offer the services of the customized content development, training, and the implementation support for lean management, Lean Six Sigma, and project management. So we are accredited by the Council for Six Sigma Certification. They are the number one leading certification agency in the globe, and we are our green belt and black belt courses are accredited by them. And we are also the authorized training partner for the project management certification PMP. And so we regularly run this Lean Six Sigma, green belt and black belt courses. And project management professional, PMP also, we offer this 35 hours PD certificate. That training also we conduct every month. Every month one batch we conduct. So that is a small introduction about our company. And first I would like to take a poll to just get an idea about the mix of the people, like the participants, like which vertical you are, like how many years of experience and all, so that I will be able to like present my presentations accordingly. So 1 second. I'll just give you a 2 minutes time to just go through this, and then we can. Okay, thanks for the participation. I think so. Most of the people are from others. Manufacturing, I think most of the people are from manufacturing and others are something. Okay. Okay. Thanks for the feedback. Okay. So how many of you have previous exposure to Lean Six Sigma? Can you just type yes or no? Do you have previous exposure to Six Sigma? Yes or no? Okay. So it is almost half of. Okay. Those who know, like, can you just tell me in one word, like, what is Six Sigma about? So what is Six Sigma? You can unmute yourself and talk. What is Six Sigma? What does it deal with?
So it is a methodology
Ah,
to uh, process improvement and minimization of error in the process.
okay. So how does it help in process improvement? Any idea?
In case in, in process wise, we decrease we identify the error and you have to prevent the error in before stage.
Okay.
So the process will be automatically improved.
Okay. 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 That's totally right. Okay. Now I will just share my screen. So I like to start this session with a small story from Mahabharata, one of the greatest epics of India. So one day, Guru Dronacharya, who was uh, giving the training on war-related things to the both Kauravas and Pandavas, he called all his students to a river bank, and on a tree on the river bank, he placed a bird made of clay. And the target given to all their students was to hit the bird in one arrow. So first came Duryodhana, the eldest of the Kauravas, and when he started taking the aim, the Guru asked him, "What are you seeing?" Then Duryodhana told that he seen the bird. Again, the Guru asked him, "What else are you seeing?" So Duryodhana, he wanted to impress the Guru, and then he started telling that I'm seeing uh, the tree behind, I'm seeing the river behind, I'm seeing the mountain behind, and so on. And the Guru checked whether his arrows, he was taking uh, the aim properly, whether he was taking care of the breeze that was passing at that point of time. So he was not convinced with the inputs and process conditions of Duryodhana, and he asked him to quit even without the making an attempt. So like that, one by one, all the Kauravas and Pandavas came, and when they started taking the aim, the Guru asked him and was asking the similar questions, and the disciples were giving the similar answers, and the Guru asked them to quit even without making an attempt. So last came Arjuna, the most favorite disciple of Guru Dronacharya. And when he started taking the aim, again the Guru asked him, what are you saying? Then Arjuna told that I am seeing the bird. Again the Guru asked him, what are you saying? Then Arjuna told that I am seeing the eye of the bird. Again the Guru asked him, what else are you seeing? Then Arjuna told that I am seeing the eyeball of the bird. So again the Guru checked whether his bows and arrows were made of good quality material, and whether he was holding the bow properly, whether he was taking care of the breeze that was passing at that point of time. And once you are satisfied that Arjuna's inputs were right and his process conditions were right, then he was 200% confident that Arjuna will hit the target, and he gave the approval for Arjuna to shoot the arrow. Then Arjuna shot the arrow and it went and bang hit the eyeball of the bird. So even though this story is a few thousands of years ago, the moral of the story is holding good even for the modern day today. The approach, what we call as a process approach, which is one of the basic principle of Six Sigma. So before going into the process approach, let us try to understand what is a process. So a process is a set of activities done to convert the inputs into outputs. So for a manufacturing process, the input is the raw material we are giving. So we may be producing some automobile components or electronic components or plastic components or some machines or whatever it is. So we are giving the inputs, the raw materials as the inputs, and we get the required outputs as the components or the machines. And for the IT service or the software development, again, the input is the information what we are giving, and the output is the report or the software, etc. So the let us now take the example of the digestion process. So in the digestion process, the input is the food what we are taking, and the input is processed into the different organs like the mouth, the teeth, intestine, small intestine, large intestine, stomach, kidney, and so on. And finally, the output what we are getting is the uh, energy and excreta. So maybe one day you had a problem that you have stomach indigestion. So you just went to the doctor and told him that you have the problem of stomach indigestion. Immediately, the doctor will try to ask the question to you like, what did you have yesterday? Did you have any this kind of problem? How long you are having? So does this problem happen frequently and all? So he is trying to assess what is the problem in the inputs or the process condition. Then maybe you may tell him that 2 days ago you had some the pizzas in the outside restaurant, and only after that this problem is happening. Then he will analyze that the problem is because of the outside pizza you had, and then he will give the medicine accordingly, and your stomach indigestion problem is going to be resolved. So similarly, in our processes, we always have problems in the outputs. We have problems in achieving the required yield. We have the problems in achieving our on-time delivery. We have the problems in achieving our productivity. So we are always under pressure from all our senior management to just to solve the problems in the outputs. So in our endeavor to solve the problems in the outputs, we seldom have the time to just analyze what is the problems in the inputs and process conditions. We just gathered some 3 or 4 of our colleagues from different departments and then do a brainstorming session, find out some 5 or 6 possible root causes. Then we just work upon an action plan, implement the action, and then for a week or two, it seems the problem seems to have solved. But again, after some time, again, the after 2 3 weeks, again the problem is going to come and haunt us. So the process approach says control the inputs, control the process conditions, the output will be consistent. So this is what Guru Dronacharya was trying to do with his disciples. With all his other disciples, he was finding that either his inputs were not right or his process conditions were not right. So he was not confident that others will hit the target. But with Arjuna, he found that his input was right and his process conditions were right, and he was 200% confident that he will hit the target and gave the approval. So the process approach says control the inputs, control the process conditions, output will always be consistent. So I will just write it for you. Control the inputs, control the process conditions, the output will always be consistent. So whenever you have a problem in the output, don't bother too much about that. Try to control, try to find out what is the problem in the inputs and process conditions, and then your problem will be solved. So that is the first basic principle of Six Sigma. The second basic principle is about variations. Whenever we talk about the Six Sigma, then we need to understand what is variation. So variation is simply a deviation from the expectation. For example, we have this height. The all of them are the human adults. All are adult female, but you can see there is a variation, right? So again, the variation is seen in the height of the human beings, their weight, the blood pressure, the body temperature, etc. And even when we are processing any material or any information, then we always have any variation. This variation is inevitable in any process. For example, let us take a simple example of taking a 10 millimeter rod and then grinding it to 11 millimeter, grinding it to 9 millimeter rod. So we just initially set the machine to give an output of 10 millimeters, and then we start running the machine, and within 1 hour we produce 5,000 pieces, and then take some random samples of 100. So all the 100 numbers we are not going to get exactly 9 millimeter, right? So we may get 8.9, 8.8, 10.2, 9.1, 9.2, and all. Always there will be some variation. So this variation in the output is caused by the variations in the inputs and the process conditions. As we have seen in the previous slide, the outputs are always influenced by the inputs and the process conditions. So sometimes the variation in the process is too large that we start producing the defective. For example, in this case, let us say that the customer is willing to accept from 9 plus or minus 0.5. So initially, your process was, that means he is willing to accept from 8.5 to 9.5. So initially, your process was producing from maybe 8.7 to 10.3, and you were getting 100% yield, and you were very happy. But suddenly, one of the bolt in the machine broke, and because of that, the vibration started increasing, and because of that, the variations increased. And now your process is producing from 8.2 to 10.8. So that means your process is producing defects not meeting the customer requirement. So the higher the variation in the process, the higher the defect levels are there. So the Six Sigma focuses on reducing the variation in the processes and improving the quality of the products, processes, and service. As I think you were saying just before, so Six Sigma definitely helps you to reduce the defects by reducing the variations in the inputs and the process conditions, right? So for a process running at a Six Sigma level of process capability, the defect rate is only going to be 3.4 defects per million opportunity. We call it a DPMO, defects per million opportunity. So, for example, you assume that the aircraft landing is a process, and if in a month across the globe 1 million aircraft landings are happening, so out of these 1 million landings, only 3 million landings are going to be defective. So, such low is the defect rate, so that the quality is going to be very good. The customers are going to be very happy, and the employees are going to be happy. The profitability is going to be very good. So that is the reason most of the companies, they just want to implement Six Sigma in their organizations, right? Okay. Okay. So when we talk about the variations, again, there are two types of variations which are creating the problem for us. So the first one we call it the common cause variation, and second one is the special cause variation. We also call that as a assignable cause variation. So let us try to understand this concept by just giving an example. So I will just take the help of the whiteboard to just explain what is the difference between the common causes and special causes. 1 second, 1 minute. Okay. So for example, let us take the example of commuting from your office to home. So for example, let the office to home every day. So maybe they are 30 kilometers apart. And if I ask you, like, how much time does it take for you to commute from office to home, then you may say that it takes around 60 minutes. So when I say that is it taking exactly 60 minutes every day, then you may say that not 60 minutes every day exactly, but it is varies, maybe from 30 minutes to 90 minutes. So maybe on some days when you are starting very early from your home, or when you are returning very late in the night to home, maybe the time you are taking is only 30 minutes. But on some other days when you are traveling at the peak of the traffic, then you are taking as high as 90 minutes. So this is what we call as a common cause variation. This is a variation. And if you really see why these variations are happening, then you can find that there are two types of causes. So the first type of causes are always happening. Every day and day in and day out, these are happening. So we are always happening. So we call this a common cause variation. For example, the number of traffic signals, the waiting time in the traffic signal, the road conditions, the weather conditions. So these are all always happening in the process, and then this is creating the variation. We call it the common cause variation. So common causes are always present in the process, whereas the other type of causes is the creating the variation, the special causes. So yes, Ravi, any questions, Ravishankar? So special cause variation means these are happening rarely in the process. The causes which are happening rarely in the process. For example, maybe on a particular day, there was a major accident. So because of that, the traffic was diverted. On that day, it took around 4 hours for you to travel the distance. On some other day, there was a major political procession was there. And on that day, it took around 60 hours, 60, maybe 6 hours for you to travel the distance. So this causes like the traffic, the accidents or the political processes do not happen on a daily basis. So even though on those days when it is happening, maybe the impact is high, overall the impact of the common causes is very high in the problems. So Six Sigma helps you to reduce the defects by reducing the variation due to the common causes. So again, I will write it for you. So Six Sigma reduces the defects due to common causes. Because these are always happening, so this will have the major impact on the problem. And we use the statistical tools. The unique feature of the Six Sigma methodology is we are using the statistical tools for solving this problem, right? So when you talk about Six Sigma, then you need to know that it helps you to reduce the defects and uh, reduce the defects because of the common causes variation and uh, the defect level when a process is running at a Six Sigma level is only 3.4 defects per million opportunities, right? Okay. Okay. Now I will go back to the slides. Okay. So this is what you will just see when after doing a Six Sigma project. So you can see that before doing the project, let us assume that this is done, project is done to reduce the scrap in a chemical process. So before doing the project, the average rejection was around 21%, and the variation was from 15 to 25%. But after the Six Sigma project was taken up and the root causes were identified and permanent corrective actions were taken, then the defect rate, the scrap rate came down drastically to around 8%. And you can see the variations also reduced from 6 to 10%, right? So this what will happen if you do a Six Sigma project. There will be a dramatic improvement in the metric taken for improvement. At the same time, there will be a dramatic reduction in the variability in the process also. So now let us try to understand what is Six Sigma. So Six Sigma is a data-driven, structured statistical methodology for problem solving. Right? It is a data-driven approach. So whenever you do a Six Sigma project, then you need to collect a lot of accurate data from the process. And this accurate data, you will have to analyze with the help of the statistical tools to find out the critical root causes. And then you will have to take some improvement action. So validating the critical root causes using the statistical tools is a unique feature of Six Sigma. So this methodology was first implemented in Motorola in the year 1987. So in 1987, Motorola, and then it was implemented in Allied Signals in 1990 and General Electric in 1995. So initially, it was implemented only in manufacturing companies, but starting from the year 2000, again, this methodology is being implemented in both software development and IT service companies also. And if you think that some new concepts or new tools were developed because of Six Sigma, it was nothing like that. It was only the consolidation of the existing tools and concepts, right? So, for example, the design of experiment, which is used for optimizing the process condition, that was existing even during the 1940s. The hypothesis testing, which is the statistical tool used for validating the critical root causes, was available even in the year 1900s. And the control charts, which is used for controlling the process conditions, that was available even during the 1920s. Right? So no new inventions of tools or concepts were developed because of Six Sigma, but it is only the consolidation of the existing tools and concepts. And we are going to follow a structured methodology, which is called as a DMAIC methodology. So the DMAIC methodology stands for define, measure, analyze, improve, and control. So any Six Sigma project will have to necessarily go through these 5 phases. Each phase will take around 5 to maybe around 4 to 6 weeks. So typically a green belt or a black belt project will take around 6 to 8 months for you to complete. So it is not a quick quiz solution for solving the problem. So you need to do a thorough analysis of the root causes and then solve the problems, right? So there are two major driving forces for Six Sigma, that is the customer satisfaction and the financial benefit. So any Six Sigma project will start with identifying the problems what the customer is facing because of our product or services. And then we also have to see how much of the financial benefits we are going to get. Because since we are going to collect a lot of data and analyze with the complex statistical tools, then it is going to be a very extensive work. Efforts are going to be more, and accordingly, the financial benefits also has to be more. Okay. So now we learned about the DMAIC methodology. There is a define, measure, analyze, improve, and control. So let us now try to understand what what activities we are doing in each phase. So first we talk about the define phase. So in the define phase, we first identify the customer. We identify the customer who is having a problem with respect to our product or service, either with respect to our price or quality or delivery or price, right? Or response time. Identify the customer who is having some problem. Then we listen to the voice of customer. We call it a VOC, voice of customer. So talk to him and try to understand what is the problem he's having. So whether there's a problem with the quality, price, or delivery, and then link it to what we call as a critical to X factor. So this X can be anything. It can be CTQ, critical to quality. It can be CTD, critical to delivery. It can be CTP, critical to price, and so on. So we talk to the customer, try to understand what is the problem they are having, and then link it to a critical to X factor, and then link it to a measurable metric. We call it a Y metric. Right? Why you are calling it as Y, I will just explain you. So it is a measurable metric. So for example, if the customer is saying that, okay, I don't have any problem in your price or the quality, but I'm having some price, I'm having some issues with respect to your delivery. So that means the customer is talking about the critical to delivery and how you are measuring your delivery performance. You are measuring the delivery performance in terms of the percentage on-time delivery. So link it to a critical to X factor and then to the Y metric, and then try to see what is the current status. Maybe you have agreed with the customer that you will give him delivery percentage on-time delivery at 95%, but currently your on-time delivery is only 80%. Then there's a huge gap between what you are achieving and what the customer is requiring. Then this ideal problem that can be taken up as a Six Sigma project, right? So you just uh, write the problem statement, then what is the target you want to achieve, then define the scope of the project, and then appoint a project leader, project team, then write the business case. So what are the benefits of taking this project? What are the problems you are going to face if the project is not going to be taken up? And then document everything in a document which is called as a project charter. So the project charter is the one of the major deliverable in the define phase of the Six Sigma project. Then during the measure phase, you just start collecting the data. So whatever the problem you are trying to solve, what are all the possible root causes for the problem? So you try to just find out all the root causes, and then we just do a measurement system analysis to ensure that the measurement system is capable of giving the accurate data. So we call it the measurement system analysis. Because if you're not making the accurate measurements, then your data is going to be wrong. And if the data is going to be wrong, then the analysis, whatever you're going to do, is going to be wrong. So you'll have to ensure that the measurement system is right. And if there's a problem, then you will have to take some corrective actions like the calibration of the instruments or the training of the people and so on. And only when your measurement system is accurate enough to give the accurate data, then only you should start collecting the data. And then you also do a process capability analysis. So what is the process capability? So how much of defects your process is producing now before the improvement? Then you also calculate the process capability after the improvement is completed, and then you compare the apple to apple, and then establish that the real improvement has been taken place. So that's what you do in the measure phase. So in the analyze phase, whatever the data you have collected during the measure phase, you are going to analyze with the help of the statistical tools, and then you are going to find out the critical 3 or 4 root causes, 3 to 4 critical root causes. So you'll find that only 3 to 4 critical root causes are contributing substantially for the problem. And in the analyze phase, you are going to validate those 3 or 4 critical root causes with the help of the statistical tools. Then during the improve phase, you are going to take action only on those 3 or 4 critical root causes. And in the control phase, you will find that by closely monitoring and controlling 1 or 2 critical root causes, you will be able to get a consistent output, right? So that is what is the basic methodology behind the DMAIC methodology, right? So first you start with the customer, identify the customer, talk to him, and then identify what is his pain area, link it to a measurable metric, and then quantify the current status, fix the target, and then define the scope of the project, and then you just appoint a project leader, project team, write the business case, and prepare the schedule, budget, and document in the project charter. And then collect the data, then find out the 3 or 4 critical root causes, take action on those 3 or 4 critical root causes, and then put in some control mechanism in place so that by closely monitoring and controlling 1 or 2 critical inputs, you will be getting a consistent output. So this is what is the problem solving strategy in the by using the Six Sigma methodology. So initially you start with the doing a fishbone diagram. I think you would have heard about this. How many of you have heard about this? Can you just put yes or no? We also call this a cause and effect diagram or a Ishikawa diagram. How many of you know how to do this? Okay, yes, I think many of you have known. Yes, it is one of the 7 QC tools. Yes, fantastic. So you do a fishbone diagram. So around 8 to 12 people from different departments and different levels. So you assemble in front of a moderator, and then you just try to find out what are all the possible root causes for the problem. So by doing a brainstorming session, so typically you may get around 30 to 50 potential root causes. 30 to 50 you will get. Then by using the various quality tools, we use a tool which is called as a cause and effect matrix. So this is a tool which will help you to prioritize the top 10 to 12 root causes for data collection. So then during the analyze phase, you use the statistical tools to just narrow down the critical 3 to 4 root causes. And in the improve phase, you take action only on those 3 or 4 critical root causes. And in the control phase, by closely monitoring and controlling 1 or 2 critical root causes, you will be able to get a consistent output. So this is how the systematically will be solving a problem using the Six Sigma methodology. So this is again sort of your roles and responsibilities within Six Sigma. So Six Sigma is actually a top-driven approach. So a lot of initiative and push has to come from the senior management, and the he has to give the overall direction for the company in what the benefits he wants to get by implementing Six Sigma, and he has to arrange for the training at the all levels, and he has to ensure that a positive environment is created for the cultural change, and he has to give a stretch target to the functional heads so that they are looking for some methodology for improvement. And if Six Sigma is offered as a methodology, then they will be immediately going for that. The champions, also called as sponsors, they are normally from the senior management. So champions are normally from the senior management. So they actually are the functional heads. So they have been given some difficult target by the CEO or the managing director, and they are looking for some methodology for achieving their target. And then they will just immediately go for it. And their main role is to provide the administrative support for the project. So when I say administrative support, so they'll be just providing all the resources in terms of the material, manpower, and the machine time for the project. And they will select the project leader, and the project team. And if there is a impediment, or if the team is not getting support from the other department, then they can escalate to the champions so that they will solve the problem for them. So the champions normally provide the administrative support for the project. Then comes the roles of the master black belt. MBB is master black belt. So master black belt initially in the organization where there is no infrastructure for Six Sigma, so they can be the external consultant to start with, but over a period of time, the internal talent can be grown. So they actually give the technical guidance for the Six Sigma project leaders. So when I say technical guidance, it is not that for the construction project, then they give the civil engineering related technical guidance. It is that they give the technical guidance with respect to the Six Sigma. So what type of data that needs to be collected from the process, and what statistical tools should be used, and how to interpret the data, and how to make the conclusion. So those type of guidance will be given by the master black belt. So they also mentor and motivate the project teams, and they also help in the project review with the senior management. So typically after the completion of each phase, like the define, measure, analyze, improve, and control. So after the completion of each phase, the project has to be reviewed by the senior management, and that will be arranged by the master black belt. And for a period of time, maybe internal talent can be grown. Then comes the role of the black belt. So black belts are normally from the senior management. Sorry, from the middle management. Managers are the senior managers, and with a strong leadership skills. So they can take up a project to solve some complex technical issues in by using the complex statistical tools, and so they also mentor and motivate the project teams, Six Sigma project teams, and their role is normally a full-time role. Either they do a black belt project on their own, or they can just coordinate some 5 or 6 green belt projects. So they are normally given a training for around 4 to 6 days of training is given for the black belts. Then comes the role of the green belt. So green belts are normally from the lower management, engineers, senior engineers, deputy managers, assistant managers, and so on. So they can do a small independent project in their own department, or they can be a part of the black belt project team. So they are typically given a training for around 3 to 4 days. So they are given training in all the statistical tools, but not as complex as the black belts. So typically they can lead a small project in their own department, or they can become a part of the black belt project team. And the yellow belts are normally the workmen or the senior workmen or the supervisors who are always present in the process, and they help the green belt or the black belt project leaders for the accurate collection of data during the measure phase. And during the control phase, they will just help the project leader to closely monitor and control the 1 or 2 critical inputs, right? So that since they are also aware of the Six Sigma methodology, they know the importance of the accurate data, and they also know how to control this 1 or 2 critical inputs, so that they will be helpful for the green belt or the black belt project leader. And white belts is mostly a sort of a awareness training given to all the people who are working in a department where the Six Sigma project is taken up, right? So that is about the overview of Six Sigma. So to just give a summary, so there are 2 basic principles of Six Sigma: the process approach, control the inputs, control the process conditions, output will always be consistent. And the second one is about the variability. Variability is inevitable in any process. Six Sigma helps you to reduce the defects by reducing the variation in the outputs, by reducing the variations in the inputs and process condition. And for a process running at a Six Sigma process level, only 3.4 defects per million opportunities. And the DMAIC methodology: define, measure, analyze, improve, and control. So that is a methodology followed for improving the existing product and existing process. And we also learned about the Six Sigma roles and responsibilities. Then we will have a quick overview about lean. What is lean? So lean is actually a systematic method for identifying and eliminating waste in the process. So this was very popular in Japan during the 1950s. So all of you are aware that the Second World War was fought between 1939 and 1945, and the war ended when United States of America, they just dropped the atom bombs in Nagasaki and Hiroshima. And after that, the Japanese economy was totally devastated, and they were working very hard to come out of their problems. And the USA, the government sent a lot of specialists from the different fields to help the Japanese to build the economy back. And the Toyotas, again, they started their automobile company during the 1935, but they were not very active because of the Second World War. And again, they became active in the 1950s, and they were the pioneers for the implementation of lean. So lean is identifying and eliminating waste in the process. So when we talk about lean, we also want to, first thing what we need to learn is about value. So value is the change in shape or form for which the customer is willing to pay. For example, if you are manufacturing a car, so you have to paint the car. So the customer is paint of the color of the choice by the customer. So the customer is paying the money for painting it once, right, which is included in the cost of the car. But because of some issues in your production process, maybe there was a rework and you had to spend some 20,000 rupees extra because of the rework. The customer is not willing to pay for that because it is not going to add any value to him, right? So any activity which is not adding value to the customer, we call this a non-value added activity. So we call this a non-value added activity, and we call this a waste, right? So by lean methodology helps you to identify and eliminate this waste in the process. So simply lean means creating more value for customer with few resources. So if you want to coin a slogan for lean, then you can say lean means more with less. So that means more output with less inputs. With less inputs. More output with less inputs. For example, now assume that you are just making a product and you are selling it at 100 rupees. And when you are producing that, the cost of production is 90. So your profit is 10. But if you are going to implement lean, then you are going to provide more features and functions for the customer. More, you are going to create more value for the customer. So the customer is willing to pay more. So he is willing to pay 110. Whereas you are going to do it with lesser resources. So your cost price is going to come down to 80. So your profit is going to be 30. So that means 3 times your profit is going to improve by implementing lean. So that is the reason why most of the companies, they want to implement lean. So lean will help you to systematically reduce the cycle time, defects, inventory, and respond quickly to the customer. So like Six Sigma, lean is also a top-driven approach. Again, a lot of initiative has to come from the top. And again, one of the very important reason why the companies, they want to implement lean is that, for example, during the 1970s and 80s, when not much of competition was there. So if you want to just increase the profit, then what you can do, you can just simply increase the selling price. Increase the selling price, right? No need to do anything, any reduction in the cost, you just increase the selling price because there was no competition. But now, after the 1990s, when a lot of the competition, not only from the domestic, but even from the export market came, then the increase in the selling price is no more an option. In fact, the selling prices always keep on falling. So if you want to even increase the profit or even if you have to maintain the profit, then the only thing what you have to do is to reduce the cost. So for reducing the cost, for improving the efficiency, then you need to implement lean, right? So the lean and Six Sigma will complement each other, and then will help you to improve the processes. And when we talk about the lean, and we told that it is identifying and eliminating waste in the process. So there are 8 types of waste which are happening in any process, irrespective of whether it is a manufacturing process or a IT service process or a software development process. So this 8 ways is applicable. So these 8 ways can be remembered by remembering the word downtime. So where D stands for defects, O stands for overproduction, W stands for waiting, N stands for non-utilized talent, T stands for transportation, I stands for inventory, M stands for motion, and E stands for extra processing. So let us quickly go through. Maybe I will just go through this. Okay, it's also called as T mode. Yeah, T mode. So currently now it is called as a downtime. Okay. So defects means any rejections or any scrap or rework, whatever you are doing in the process, we call it as defects, right? So in a manufacturing setup, it is very easy because it is very visually it is seen. But in a IT service or in a software development, then what may happen is maybe people are sitting in front of their computers. We are thinking that they are doing a very good job, but they may be doing some rework or whatever the work they are doing may be abandoned, and then they may take an entirely new approach. So that is going to be a waste. So defect is any waste due to because of the scrap. Overproduction. So producing more than or before it is needed, we call it overproduction. So if you are going to produce any items without any firm order from the customer, we call it as overproduction. So if in case the customer is not giving the order, then whatever we have produced will remain in the inventory. And after some time, maybe what may happen is maybe the design of the product itself has changed. And then the current product is going to be like obsolete. Then everything is going to go as a dead inventory. So in order to avoid overproduction, what you need to do is you should always produce the right product. So whenever I say right product, you should always produce only the items for which you have the firm orders at the right time. You need to produce only when the customer requires the material, right quantity. If the customer is asking to send 200 items every week, so you just produce and send 200 items every week. Don't produce a monthly quantity of 800 and then send it in one lot. That means in that case, you are sending it earlier than needed. That is going to be a waste. Right quantity with the right quality. So always produce only with the firm order from the customer, right? And deliver on time, not before or not later than required by the customer. Waiting is a wastage because of the any job which is waiting because of maybe the manpower is not available or material is not available or machine time is not available. So waiting time, any time wasted on waiting for the next job process, we call as a wastage due to the waiting. Fourth one is the non-utilized talent. So I have asked this question in many of my sessions to my students, and just I ask them like what percentage of your capabilities are being currently utilized by your organization. And then typically they give an answer around 50 to 60%. So only 50 to 60% of the employees' capabilities are being utilized by the organization. So that means 40 to 50% of their capabilities are being wasted. So the organization has to recognize this wastage, and then they'll have to take the appropriate action. So Japanese companies are very good in this, and then the bond between the employees and employees is very good in Japanese company, and they always ensure that they utilize the talent of their employees, and then they motivate and keep the employees engaged so that their output is going to be productivity and quality is going to be very high. So non-utilized talent is one of the major wastage. The wastage due to transportation is mainly because of the layout issues. So initially, maybe you have started your company with a lesser capacity, but after 5-10 years, maybe when the company is growing, so you are buying more machineries, but you are keeping the machines only where the space is available. And accordingly, the material movement is going to be becoming zigzag. And then that is going to again cause a lot of wastage and also unnecessary movement. So a lot of power and fuel may be wasted. And because of the frequent transportation of the material may be damaged and scrap may increase. So many times what may be advisable is you just do a complete stop the production for a week or two, do the entire relayout of the machine, and then you start the production afresh. Then that will be better rather than having a ineffective layout. So transportation is again mainly because of the layout issue. The sixth one is the inventory. That is the excess products and materials not being processed. So any material you are producing, so only when you are delivering to the customer, then only you will be able to realize the money, and then you will be able to pay the salaries to your employees and pay for your suppliers. But if the materials are going to lie inside the factory, either as a raw material or work in progress stage or the finished goods stage, then it is not monetized. Then it is going to be a problem. So you won't even have money to pay the salaries to the employees. So inventory is the biggest enemy as far as the lean is concerned, and you should take all efforts to reduce the inventory as much as possible. The seventh one is about motion, that is unnecessary movement by people. So if while you are operating a machine, so somebody has to either bend a bit or stretch a bit to unload, bend a bit in order to load the machine, and then he has to walk some 50 meters to transfer the material to the storage area. So this bending, stretching, and walking is going to make the person tired too soon, and his efficiency is going to be reduced. So we need to give a proper working tools and working environment for the people. So if the people are made to work in the place where a lot of heat is there, a lot of dust is there, a lot of noise is there, then there is going to be a problem. So you'll have to give them a proper working environment, and you will also have to give a proper working tools, so that if people have to carry some heavy weight, you just give them appropriate handling tools so that they can handle larger weight with a minimum of effort. So giving the proper working environment and working tools will help you to reduce the rejection wastage due to the motion. The last one is about the extra processing. So extra processing means doing more checks or the quality checks more than what the customer wants. Sometimes what may happen is maybe there was a quality issue with your customer. So for in order to as an ad hoc basis, the management took a decision that after the quality control inspector done the QC, one more check will be done by the quality supervisor. But after 1 year also, if the same process is going to continue, that is not really advisable. That is extra processing more than what the customer is wanting. So we need to identify where these 8 types of waste is happening in our processes and take action to reduce this. So these are some of the most commonly used lean tools. So Kaizen is actually a small improvement. So mainly in many companies, this is implemented as a Kaizen scheme. So any employee who is having an idea, they can just fill up a form, and then they can drop it in the Kaizen box. Then that will be opened at a periodic interval. Small gift will be immediately given as a token of appreciation for taking part. Then the suggestion will be forwarded to the manager, and upon their approval, then the employees will be given the opportunity to implement. And maybe once in a month or once in a quarter, some recognition and rewarding can be done to the people who have done the active part in this effort. So again, the value of the money, value of the reward is not very important, but the fact that it is given by the topmost person in the organization in front of all the employees, that is going to motivate the people to do a better job. So that is about Kaizen, small improvement. Pokayoke is a mistake proofing. So this is like this will help you to avoid the manual errors. So the Pokayoke, what we mean is we are trying to put in some control mechanism in place so that even if someone wants to deliberately make a mistake also, the system will not allow them to make a mistake, right? So the chances of any manual error is going to be totally avoided. For example, you get into your car, you forget to secure the seat belt. After running for a few meters, you will get an alarm saying that the seat belt is not secured properly. So until unless you just secure the seat belt, the alarm is going to continue. Same way, same thing about when the door is not open, closed properly, or when the handbrake is not released. Same way, for example, when the microwave oven, the manufacturers know that if somebody is going to open the oven when it is in a switch on condition, then it is going to be injurious to the health. So the design of the machine is done in such a way that somebody is going to open that in a in a switch on condition, automatically the machine will get off switched off. So that is an example of ICEQB. Help you to avoid any manual error. 5S is actually a lean tool that will help you to improve the workplace discipline. So whether you are going to implement lean or Six Sigma, it is very important that you need to ensure that the the recommendations given by the project leaders has to be implemented with a lot of discipline. So for that, we can use the 5S. So 5S stands for 5 Japanese words: Seiri, Seiton, Seizo, Seiketsu, and Shisuke. And so first we'll have to sort out what is required and not required. Not required items are to be removed from the workplace. Then whatever the required items, we will have to arrange in the systematic order so that the searching time is going to be reduced. Then we'll have to clean the workplace, and we'll have to do the proper maintenance, daily, weekly, monthly, and annual maintenance, so that the breakdown and the downtimes are going to be reduced. That is shining or cleaning. Then whatever the work we are doing, we'll have to standardize the work, and we'll have to put in some visual tools in place, visual management tools, so that we'll be able to visually know what is happening in the floor and sustain. In order to sustain the improvement, then we'll have to do some audits, and we'll have to the senior management has to visit the workplace on the regular periodic intervals. And again, the recognition and reward can also help in sustaining the improvement. So that is about 5S, mainly used for workplace, improving the workplace discipline. Kanban is actually a lead tool which will help you to control the inventory. So it's a visual management tool for inventory control. So typically, you just in the workplace, you just mark some low, the minimum inventory and maximum inventory. And by controlling the operations of the machines, you are going to control the inventory between the minimum and maximum level, so that the inventory is going to be reduced. So that is what is Kanban. Just in time is again like whatever the material is required, you just buy it only when it's needed, so that you don't have any inventory at your place. So that is what is the just in time. So these are some of the most commonly used lean tools. So then while you are defining the project, then you will have to prioritize the problems for solving. Right? For example, you are doing a project to reduce the scrap from maybe 10% to 2%. So there are maybe 20 different types of defects are there. So the Pareto diagram will help you to narrow down the scope of the project. So it will help you to prioritize the problems for solving, and it will help you to narrow down the scope of the project. So this word Pareto is derived from Wilfredo Pareto. So he was an Italian economist who lived from 1848 to 1923, and he was doing a research on how the wealth of Italy was distributed among Italians. Then he found that the wealth distribution was not equal. 80% of Italy's wealth was distributed only among 20% of Italians. That means only very few Italians, they were owning a chunk of Italy's wealth. So this is also called as the 80-20 rule. And it was first used for problem solving by Ishikawa, who was a Japanese quality guru. And he told that 80% of the impact of the problem, 80% of the impact of the problem are caused by only 20% of the causes. So if you are able to identify these 20% of the causes and take action to eliminate, then 80% of the problem is going to be solved. So I'll just give an example so that it will be easy for you to understand. So for example, you assume that you're working for a IT service company, and in your company, there is a main tool. Whenever you have any hardware or software issue, you can raise a ticket in the software. So maybe in a month, around 1,000 tickets are raised per month. And you can raise a ticket for any of the 20 causes. So there is a drop down of 20 causes, and you'll have to select the appropriate one. So the project team was formed to just reduce the number of tickets, and they just analyze the data for 1 month. So what are the different causes which are for which causes the tickets are raised? Then they found that according to the Pareto diagram, 80% of the impact of the problem. So 80% of 1,000 tickets. So that is equal to 800 tickets are caused by only 20% of causes. So 20% of 20, that is equal to 4 causes. So 4 causes are contributing to 800 tickets. So if you see the mouse issues, keyboard issues, and unable to install software, so these 3 itself are contributing to the 85% of the problem. So if you are able to take action to resolve these 3 issues, then a majority of the problem is going to be resolved. So this is what we call as a Pareto diagram, and this will help you to narrow down the scope of the project so that your project becomes very focused. Then as I was telling you, the project charter is one of the major deliverable from the define phase. So the the project charter has got 6 major elements: the problem statement, the goal statement, the business case, timeline, scope, and the team members. So first we start with the business case. So the business case is actually the business reason for taking the project. So what are the benefits we are going to get by doing the project, and what problems we are going to face if the problem is not going to be resolved? For example, assume that one of your premium customer has been complaining for the last few years that 3% of whatever the items you are sending to him, he is unable to use. And he is asking you to reduce it to less than 1%. But there has been no action improvement from your side. Now he has given an ultimatum saying that if you are not going to reduce the defect, then he is going to stop buying from you. And currently you are supplying around $1 million worth of material to him, and 20% of your margin. So $200,000 you are earning as profit every year. So if the customer is going to stop buying from you, then you are going to lose this $200,000 as a profit. And if you are going to take up this project and reduce the scrap to less than 1%, then you are going to save around $200,000 because of the reduced rejection. So the net benefit will be $400,000, right? So whenever you are writing the business case, you have to give the justification for doing the project. So what are the benefits you are going to get by doing the project, and what problems you are going to face if the problem is not going to be solved, right? So the benefits, again, you can classify into tangible benefits. Tangible benefits are those which can be measured in terms of money. And intangible benefits which cannot be measured in terms of money. For example, the customer satisfaction, employee satisfaction, these are very important, but we cannot measure in terms of money. So while we are writing the business case, you will have to document both the tangible and intangible benefit. Then the problem statement. So what is the problem? You have to just give a very crisp statement. So again, 1 page or 2 page problem statement may not be required. So you can just make a single sentence. So the problem statement should contain the metric for improvement. What metric you are trying to improve? Then what is the current status? And how long the problem is existing? How long the problem is existing? For example, you may say that currently the percentage on-time delivery is less at 80% based on the data from January to December 2025. So the metric is percentage on-time delivery and current status is 80% and how long is for the last 1 year. The goal statement again should identify the metric for improvement. Then what is the target you want to achieve and by when. So again, a typical goal statement will be the objective of the project is to improve the percentage on-time delivery from 80% to 95% by June 2026. Right. So again, very crisp, one sentence problem and goal statement will be enough. No need for you to exaggerate that. Then the timeline, the start and end date for each of the phases, define, measure, analyze, improve, and control. Then scope of the project, what is inside the scope of the project and what is outside the scope of the project. So it is always better to focus the project on a single process or a single customer or a single defect type, right? So that the project is going to be very focused. Then the team members, like who is the project leader, who are the project team members, and it is normally the project charter is signed by the project leader, the master black belt, champion, and the finance representative, who will be validating the savings at each phase of the Six Sigma project, right? So that is in short about the project charter, which is one of the major deliverable from
Hello.
the, yeah. Okay. So now we will learn about case study, just to see how the DMAIC methodology can be used for solving a problem. So this is based upon my own personal experience. So there was a first day when my daughter had gone to the school after the summer vacation. And when she came back, then I found that she was feeling very sad. So when I asked her the reason for her sadness, then she was reluctant to come out with the real reason. But when I put a lot of pressure on her, then finally she told that she was feeling bad as when all her other friends were explaining about their wonderful experience in an exotic location during the summer vacation. So she was feeling bad because she had nothing to say because she had not gone anywhere outside for the summer vacation. So I was feeling even bad because I was the one who did not take her for the summer vacation, even though I was earning around $120,000 per annum for the last 5 years. I was unable to save even a single penny, so that I was not able to take her for the summer vacation. Then since there was the freshly I have done this Six Sigma, then I thought why this problem cannot be solved by using the Six Sigma methodology. So in the define phase, we have solved with the customer. So here the customer is my daughter, and voice of customer says that I'm not feeling bad. I am feeling bad because I didn't have anything to say about my holiday. That was the voice of customer, and linking it to a critical to X factor, that is critical to cost, money, right? Critical to cost. Then linking it to the measurable metric, that is a savings. So if I had enough savings, then I would have taken her for the vacation. Metric for improvement is the saving. Problem statement again has to identify the metric. So the metric here is the saving. And what is the current status? Current status is 0%. And for how long the problem is existing? For the last 5 years. So all the three mandatory elements are there in the problem statement. Goal statement is to increase the saving from 0% to 5% within 3 months. So again, the goal statement has identified the metrics. There is a saving. Target is 5%, and by when is within 3 months. And the business case, the expected annual saving is around $6,000, and the project timeline is 3 months. So these are the major elements of the project charter in the define phase, right? So in the measure phase, then I started collecting the data. I had the data on how this $120,000 was spent on various different heads. I had the account. So with that, I just created the Pareto chart. So we found that the rent, food, shopping, so these three itself were contributing to around 70% of the problem. So out of this rent, I could not do much about that because my house was in a area where the least rent was there. And again, that area was close to my office and the schools of my children. So I cannot do much about the rent. But about the food, we ourselves were surprised when we knew that we are spending around $30,000 for the food. So we thought that we will just focus only on the food expenses. So whatever the $6,000 we wanted to save only on the food expenses. So by using the Pareto chart, we are now able to narrow down the scope of the project only to the food expenses, right? So a very important step we will have to do in the initial stage of the project. Because if the scope of the project is going to be very high, then it will take a lot of time and effort. And most of the time, it may get stuck up somewhere during the measure or analyze phase. And so it is always better to narrow down the scope of the project. Many times the project leaders, they make a mistake of taking a very high scope of work. For example, when I was consulting for Amazon, then one of the project leader came and told me that he wanted to do a project to reduce the percentage, to reduce the percentage product returns from 1.6% to 1.4%. So this, everything was fantastic. So he has identified the metric, that is the product return. Current state is 1.6 and target is 1.4. Everything is okay. But when he defined the scope of the project, he told that he wants to do it for all product lines for the worldwide marketplace. Right. So if you see that that Amazon is dealing with tons and tons of thousands and thousands of different products, and they are active in more than 80 countries. So if you are going to take a project whose scope is going to extend to thousands and thousands of different products and the more than 80 countries, then it is very difficult to collect the accurate data from the process and then find the critical root causes for the problem. So such type of projects may get stuck up somewhere during the measure phase or the analyze phase and then may be later abandoned. So many times the project leaders, just to show a very high savings, then they may take up such a huge project. But again, that is not advisable. Always try to, instead of that, if you are going to say that the objective of the project is to reduce the percentage product return from 7%. So if you are going to say that the objective of the project is to reduce the product returns from 7% to 2% for the t-shirts for the US market. So then now the project is well defined, right? So always try to narrow down the scope of the project by using the Pareto chart, right? That is very important. Then during the measure phase, then I just had, since that now I have decided that I will go for only the food expenses, then I had the uh, data on how the money was spent. $30,000 was spent on month-wise, right? So here you can see that the currently it is $3,000 $30,000 per annum. That is $2,500 per month. So that is what is the current status. And my target was to move down to 2,000, right? That was my target, $24,000. But you can see that out of this 12 months, at least 4 months, I have achieved lesser than the target or something very close to the target, right? So 1,775, 1,650, 2,025 and all. So 33% of the cases I have already achieved something lower or nearer to the target. But since I did not know what are the root causes which are contributing to this lower spending, so since I didn't have any knowledge about that, I didn't have a control over them. And since I didn't have the control over them, then some few months it was going as high as 3,250 or 3,750, so that the overall the expenses is very high at 2,500. So by using the Six Sigma methodology, we are trying to find out what are the real root causes which are contributing to the lower food expenses, so that we'll be able to have a control over them, so that the overall we will be getting consistently, we will be getting around $2,000. So the moral of the story here is that we are not trying to bend the sky by using the Six Sigma methodology. We are not trying to achieve something which we have never achieved before. What we are trying to achieve is whatever the best we have achieved in the past, we are trying to achieve it very consistently, so that our efficiency and our defect rates will be very decent enough. Okay. Then in the analyze phase, then we just started with a fishbone diagram to find out what are all the possible root causes for the higher food expenses. So I just divided into the primary food, secondary food, outside food, and the snacks and beverages. So the cause and effect diagram can be like we can categorize into different categories according to our convenience. Then by using the tool, as I was telling you, called as a XY diagram or a cause and effect matrix, I was able to prioritize the root causes. So again, this tool we'll be learning in detail in the green belt or the black belt courses. So by using this tool, I was able to find out that the meat, I was able to narrow down the meat, restaurants, oils, ice creams, and chocolate. So these four were identified as the critical root causes which are contributing substantially for the food expenses. So in a typical Six Sigma project, these critical root causes will be validated by using the statistical tools. But since it's only a case study and only for the initial understanding, I'm just stopping here. But in a real Six Sigma project, you will have to validate these root causes with the help of the statistical tools. Then during the improve phase, then I just took action only on these four critical root causes. So I reduced the consumption of meat from twice a week to once in a week. So previously I was taking the meat both on Saturdays and Sundays, but now I am just, we have decided that we will take the meat only on Sundays. We reduced the consumption of oil from 4 liters per month to 2 liters per month. And we reduced the number of visits to restaurants from once in a week to once in 2 weeks. Previously, we were going to the outside restaurant once in every Sunday, once in a week. But now we decided that we will go only in every alternate Sunday. We reduced the consumption of ice creams and chocolates. So by taking all these four actions, we were able to do an initial cost saving of $6,000. Also, the health expenses also reduced from $5,500 to $2,000. So the previous one, you can see that the health expenses was contributing to $5,500, and now I am just making a claim that that has been reduced to $2,000, because these four root causes, they were not only contributing to the higher food expenses, they were also contributing to the higher health expenses because they were not healthy. And once I reduced that, then my health expenses also came down. So this is what will happen whenever you do a Six Sigma project. You do a project to improve the productivity. At the end of the project, you will find that the productivity has improved and the quality has also improved and yield also has also improved. So multiple benefits you will get by doing a Six Sigma project. Then during the control phase, then I was able to find that initially the average food expenses was quite high as $2,500, and the variation is also quite high. But after the Six Sigma project was done, then you can see that there is a sharp reduction in the average food expenses to $2,000, and the variability was also reduced. So I have done this project maybe 10, 15 years back, and now current status is my annual savings has increased to 10% of my salary for the last 5 years, and my expenses on health and loan repayment also has come down drastically. So the health we already discussed the reason. Now I am making a statement that the loan repayment also has come down. So that means initially I was not at all saving the money. So I was taking more loan, and then the loan commitments were becoming higher and higher. I was defaulting the loans, and then interest was going up higher and higher. But once I started saving the money, then I stopped taking the loans. I was repaying even before time. so that my loan repayment also over a period of time vanished. So that also came down drastically. So multiple benefits you will get by doing a Six Sigma project. You do a project to improve the productivity. At the end of the project, you will find that the productivity has improved, yield has improved, quality has improved, the customer satisfaction is improved, your employee satisfaction is improved, profitability has improved. Multiple benefits you will get by doing a Six Sigma project. So now every year, I enjoy the vacation with my family in an exotic location. And most important all, I can see happiness in my daughter's face during vacation, for which I can never fix a monetary value. So here you can see the first two, these are the hard saving, that is the tangible benefits which can be measured in terms of money, whereas the last two are the intangible benefits, which are also very important, but we cannot measure in terms of money. So that is a brief view about this Six Sigma, like yellow belt, this thing. So this at a very high level we have covered. So the real benefit you will get if you do the green belt or the black belt this thing courses, and that will really help your career. Okay. So with that, I'm just closing this session. And if any one of you have any questions, then you can just ask the questions now. Any questions or any doubts you have? Yes, Manjuna?
In the control part,
Yeah.
it is a, like what you can say, it is a, what you can say, it is a tangible benefit. See,
Mm,
after defining the root cause and analyzing and root cause,
mm,
you have you have to save the money. Okay,
mm.
control means you have to what you can say, it is an countermeasure. You have to always have an what we can say, uh, control means it should be sustained. Like in 5S we have one word, sustain, no? If
Yeah,
you
yeah.
want to keep one area room, you have
Mm,
to follow the activity day by day.
mm.
Likewise, control measure, I think it's not easy test, it is in benefits, I think so.
No, it's
Control
actually.
means you have to, if you want to go with savings, na, you have
uh,
to have
mm.
some control measures.
Yeah, so that means these are actions what I have taken, right? So if
Yeah.
these actions, if I'm going to sustain this, means without compromising on anything, so I'll have to always follow this, because out of these many possible root causes, so finally
Mm-hmm.
I have validated these are the main this thing, and this I'll have to constantly I'll have to do that. So if I do only this, then I'll be able to get a consistent output. So that's what is the philosophy.
Yeah.
Okay.
Mm.
So
Okay.
we start off with maybe 40, 60 potential root causes may be there, but
Mm.
systematically you are keeping on reducing it, prioritizing it, so that at the end, uh, so you may be thinking that, okay, my process is very complex. I'm having a very chemical process, so it is a very complex process. It's happening at some micro level. So then it is very difficult for me to control all those things. But generally, you will find that whether it is a IT service process or a manufacturing process or a plastic manufacturing or a component manufacturing, machine manufacturing, you will find that only two or three root causes are contributing substantially for the problem. That is what is the
Okay. Okay.
basic philosophy. And if you are able to identify those two or three and control it very closely, then you will be getting a consistent result.
Yeah, yeah, yeah.
Okay.
Okay. Thank you, sir.
Okay. Any other questions? Okay. So before going, maybe I will take another poll. Okay, I'm
Hello,
just launching the, yeah.
sir. If you are saying there is two to three problems, that there could be two to three root cause to
Yeah.
for any problem. So, if there are two to three root causes, it means they are all the probable root cause. They are not the actual root cause, right?
No, they are actually validated. That's why we are validating with the statistical tool. That means these are the real root causes.
Okay.
That is the actually the main this thing for the Six Sigma, right? Because Six Sigma is the only methodology, process improvement methodology, where you are using the statistical tools. So whatever you are going to narrow down, these three or four, these are actually the real root causes. So that is why you are making this as a very extensive exercise, right? Very extensive exercise.
Okay, sir. Okay.
Yeah. So maybe whatever I've shown is very this thing. And in our green belt or black belt training, what we do is we just make you to do a project from your own area of work, right? So maybe I think those who want to leave, maybe I think the time is overshot. Like I think already we have completed 10 o'clock. We were supposed to end. But I will just show you for those who are interested what actually we do because this is one of the project which was done by one of our December batch. It has recently concluded. So I will just show you. Okay,
Hello,
so
sir. I have one doubt.
yeah,
Yeah, today's session participation certificate when will be received?
by next Tuesday we'll get.
Yeah, okay, sir. Sir, and another one request. This PPT will be forwarded in mail.
Yeah. PPT and the recordings will also be shared with you.
Yeah, thank you, sir.
Okay. So typically what we do is in our green belt or black belt program. So we just have a template. So you'll be asked to like define which domain you are working and what product or service you are making, which function you are in. And then you'll be asked to select using the chat GPT, you'll be asked to select, so chat GPT will give you 10 possible problems that can be used for, which can be solved through the Six Sigma methodology. And then you will just define what actually you want to, you can select, right? Depending upon your own problems, then you can select. Then you will again identify what metric you want to improve. So again, you can give this thing like 10 metrics to define. And then you can define like which metric you want to improve. And then by using the dummy data, you can just say like what is the current status. So maybe current status around maybe this is what is the average yield or something like that, right? Internal rejection rate is so much. Then by using the Pareto chart, we are able to just say that this is what the injection molding is the process we want to take. And then we just start, as I was telling you, we go in a step-by-step process, right? Identifying the customer, who are the internal customers, who are the external customers. Then how do you identify the voice of customers? How do you link it to the critical X factor, metric for improvement? Then what is the current status? Right? These are all some of the, we also provide the mini tab free of cost, right? So that you can use it even for your day-to-day life. Then all those tools and concepts, see, these are project charter. So all those things are generated by the chat GPT, and then you can validate according to your own standards, right? So then again, the entire dynamic methodology. So this is a fishbone diagram. Again, all those are output from the chat GPT, which you can modify according to your own what do you call status.
Format.
Yeah. Then dividing them into common causes and special causes. Then this 8 waste. So again, you can give chat GPT, like I want to identify this. Then based upon that, we call this a low hanging fruits, right? So this wastage and the special causes and all, you can address immediately. So you can get some immediate improvement. So again, these are some of the improvement actions you can immediately take. Then again, this cause and effect metrics for prioritizing the root causes. And then data collection plan, what data you are going to collect. Then again, these are some of the graphical tools, what will be used for validating whether the data is right or wrong. And then the analyze phase, again, the chat GPT itself will give actually in the real project, you will have to collect it on your own. But here we made the students to do it with the dummy data as produced by the chat GPT, right? Then again, this using the root causes, like this is the multiple linear regression, it's actually a statistical tool used for validating the root causes. And then these two are identified as the root causes, validated root causes. So resin moisture content, machine. So for the injection molding, higher scrap rate, the resin moisture content percentage, machine parameter deviation, and mold temperature variation. So these are the three critical root causes. And then in the improve phase, you are going to take action only on those root causes. And then after making the improvement, again you are collecting the data after the improvement. And then you are also validating whether the data is okay or not okay. And then you just using again the statistical tool, you are going to validate whether the real significant difference is there or not. And then in the control phase, then what control mechanism you are going to use, right? So this we make all our students to do it in the class, right? So that at the end of this, the people, all the students will have this, they are confident to solve a problem in their own area of work. Okay. Okay. Any questions or any comments? You can just maybe you can just give it now. Any comments, any questions, any clarification?
Sir, actually, you have said a poll. Through that, we have to register over there. But in that poll, it is coming that this session will be start from October.
Which one?
October
Poll.
is so far now.
In the poll?
Yeah,
okay.
yeah.
Now, sorry, the poll was set longer. So actually, our batch is starting.
Since that this poll is the old that you have shared with us.
Okay. Sorry. So maybe I didn't update this. So actually, we are starting our January batch is starting day after tomorrow. That is day after tomorrow. Yeah, that is on 10th. So it will go on for 4 weeks from every Saturday, Sunday, 7:30 p.m. to 11:30 p.m. Saturday and Sunday. Sorry,
then
maybe.
How we have to register over there?
Yeah, I think our people will get in touch with you, and maybe yeah, you can just.
Many times, what is happening? We are busy in the office, and we are unable to attend the call at that time. Could you share a link or messages like that?
Yeah. So typically, yeah. So we also record the sharing. We share the recordings also. So and we also have a mobile app. So all the recordings and all the content will be put in the this thing mobile app. So you can view it and you can hear the recordings anywhere, anytime. And all the quizzes and mock tests, everything will be there available in the mobile app itself.
Okay, how much cost we have to pay for that courses?
Yeah, I think maybe tomorrow, I think maybe in a day or two, maybe our people will, again, depends upon, so there are so many permutation combinations are there, so we can just, so again, maybe by tomorrow, I think some of our people will get in touch with you.
Okay, no issue. It is our sincere request to you. Please share that the presentation which you presented at the front of us.
Yeah, sure. As I told you, like you will get the certificate latest by Tuesday. Most probably by Monday itself, you may get it, but latest by Tuesday, you will get the certificate, yellow belt certificate through the mail. And by tomorrow, you will get the recordings as well as the PowerPoint presentation.
Okay, thank you, sir. Thank you so much.
Okay, thank you.
Thank you, sir, for giving me your valuable time.
Thank you. Any questions, any other questions, any doubts, you can just ask me now. Ankit, any questions?
Sir, how I will get today allowed certification? You say today any link or I will get in email ID, sir?
You will get in your email ID. You are registered using your email ID, right?
Yes, sir.
So you will get it.
Sir, what about our new courses about the green belt certification, new upcoming courses?
Yeah, as I told you, the green belt and black belt courses, they are starting in the coming Saturday, 10th of January.
Sir, after Saturday, any other batches?
Every month we have one session. So maybe after January again, February again, it will start. So every month, every 4 weeks, you will have one batch.
Every month it started, sir?
Yeah, every month, yeah. And I will also give you share you our website address. And I will put it in the chat box. So
or you can send mail also.
Yeah, we can mail. Yeah.
Okay.
I will share it here also. It is ICEQBS.org. So there again, our schedule for the 3 months are given. January, February, March. Yeah.
Sir, could you confirm me the courses duration?
Pardon?
What will be? Could you confirm me the duration of that courses?
Total is 32 hours. So Saturday and Sunday, 4 continuous weeks from 7:30 p.m. to 11:30 p.m. IST.
Only for 1 day or?
No, Saturday 7:30 p.m. to 11:30 p.m. IST. Sunday again 7:30
Okay.
to 11:30 IST. So 8 hours no in 1 week. So like that 4 weeks. So 32 hours is
Okay.
total. Yeah, 32 hours is total.
41 course, na?
For one course, yeah.
Okay.
So we have some combination. We have green belt only, black belt only, then green belt, black belt combo will be there. So all those combinations. So our salespeople can give you more details, and depending upon your requirement and your qualification or your work experience or something like that, they will suggest.
Okay. Thank you so much.
Okay.
Thank you, sir.
Okay. Thank you. Any other questions, clarification?
Sir, what is the main difference between the Six Sigma and Three Sigma? Suppose in case of mean median mode, in the nominal distribution curve, so in the left side it is a plus Six Sigma and right side is a plus Six Sigma, or left side is a plus Three Sigma and right side is a plus Three Sigma, and both mean Six Sigma. What does
Yeah.
mean?
So it is actually -3 plus 3, -3 sigma and plus 3 sigma. So when you say that normal distribution is there, so that is actually one of the basic concept of normal distribution. So we say that when you know the process is happening, then say for example, if 100 male adults are standing in a queue, then you measure the height of all the 100 people, and then you calculate the mean and standard deviation. Then that empirical rule for the normal distribution says that the entire range will lie between mean plus minus 3 standard deviation. So for example, if the mean is you are calculating as 170 centimeters and standard deviation you are calculating as 10 centimeters, then 170 plus or minus 3 into 10. That is 170 plus or minus 30. That means 140 to 200. So that will be the range in which all the 100 people will be there.
So
Again,
it is in Six Sigma.
That's what is Six Sigma, yeah.
Okay. Okay. And what is the maximum value achievable in process capability CPK?
CPK, if it is more than 1.5, then we can call the as a Six Sigma process. But typically, most of the quality focused companies, they are looking for maybe 1.33. So standard I would have seen. If the CPK is more than 1.33, that means you are good enough. But if you want your process to be classified as a Six Sigma process, CPK should be more than 1.5.
Okay, thanks. Thanks.
Okay. Yes, Divyang Pamar, any questions? Divyang, any questions? I am seeing your hand size.
Excuse me, sir.
Yeah.
This session regarding any attendance link you sent?
Your attendance will be captured in the Zoom itself. So we will go through that, and then based upon the time spent, then we will like people who have attended for only 5-10 minutes, we will not provide. But who have been with us for a fair amount of time, that we'll get the certificate.
Yeah, okay, sir.
Yeah, that the time will be captured in the, we'll take the report from Zoom. So we provide the ISO internal auditor certificate we give. So that is actually a e-learning content from us. So if you take our green belt or black belt, then this ISO certification can be like two or three we give as a free this thing. So FMEA, ISO, 8D report, so control chart like that, we have some small courses. So that it can be free. Otherwise, you can also buy it as a e-learning content. Yes, Shivam Mishra?
Hi, sir. Sir, what the difference between lean manufacturing and Six Sigma? If anyone wants to ask with me, what's the difference between lean and Six Sigma? How you can
As I was
lean?
telling you, lean is actually will help you to improve the productivity, right? Improve the efficiency
Yes.
by reducing the identifying and eliminating the waste, right?
Yes.
Improve the quality, improve the productivity, improve the efficiency. Whereas Six
Yes, sir.
Sigma will help you to reduce the defects, reduce the variations, reduce the defects, and improve the quality. So by implementing this as a Lean Six Sigma, like both the concepts are going to be in place together simultaneously. So you're going to
Yes,
apply
sir.
both the Lean concepts as well as Six Sigma. So then you'll be able to improve your productivity and At the same time, you'll be able to improve the quality also. So that is why it is now implemented as Lean Six Sigma.
Okay, sir. Thank you so much, sir.
Okay. Okay, any other questions? I really enjoy answering the questions from you. So any questions? Okay. Thank you all for joining this. And so hopefully, I think by um, definitely before, even before, I think we can get the certificate, yellow belt. But yes, Nafis, any questions? Nafis?
Yeah, good evening, sir.
Yeah.
Yeah, sir, I would like to ask you regarding the which kinds of courses for usable for construction industry, like that Lean Six Sigma or Lean Sigma. So and a black belt and master black belt and even green black belt. Which kinds of courses for better for construction industry as well? So that's why I am asking.
Yeah. So construction, again, we have a lot of students. Again, they actually both are actually. If you see, I'm also a certified PMP, and I'm also a certified Lean Six Sigma Master Black Belt, right? So both are actually will supplement each other, right? So in your day-to-day this thing work, for example, you are having a problem. Like even I can just like how I was showing you, you can do a project, Lean Six Sigma project in your own area for construction also, right? For example, your strength is coming lesser. A lot of variation is there, right? Because of that, the building is not the same. Then how you can reduce the variability in the what do you call compressive strength or something? No? What do you measure that? In the cement, what do you measure? The strength, right? So for that type of problems, you can use the Lean Six Sigma. And then if you are doing a construction project and then you want to do it within the scope, within the budget and within the schedule, then how do you identify the risk? How do you manage the stakeholders and all? So for doing the project management, then you can do the PMP. So to answer to your question, both are applicable for you, depending upon what actually is your role. So if your role is more of
Actually,
a, if
yeah,
you're, yeah.
Actually, my role is as a QA/QC engineer, and
Yeah,
I have 10-year experience. And currently, I'm working in construction industry and infrastructure like that. So
the
same
QAQC,
for
most of the participants, especially from Middle East, they have done the Lean Six Sigma with us. So that will help you to improve the quality and improve the efficiency, right?
yeah.
So
Okay,
if
I
you
got.
are a project manager position role, then PMP will be better. But if you are in a quality role, you are into more into operations and then you want to improve the efficiency or reduce the defects, then Six Sigma will be more ideal for you.
Yeah. I know all those things about PMP rules, but I want to understand Lean Sigma, Lean Sigma, how to work Lean Sigma, and which kinds of helpful for construction industry for as a QA/QC personnel.
Yeah,
So
yeah.
I am asking.
I just showed you that project, no? So like that, again, you can just in that put that you are working in the construction industry and then you are working my infrastructure construction is a product or a service you are giving, and then you are in the quality. Then you can ask ChatGPT to give 10 problems that can be solved, right? Then that will identify 10 problems. Then you can identify which one actually is really bothering you, right? Because in your situation, in your current position, which is more relevant to you. So like that, step by step, you can just go. Maybe I can share. I think I remember one of the recent batch student he has done a project in construction. Maybe I will ask you, Nafis, right? Okay. So I will ask my people to share with you that document. So that will give some idea, like whatever problems can be solved.
Okay, sir. And if you agree, I have one more questions. Have Lean Sigma helpful for a vacancy engineer like that? How to identify root causes
Yeah, definitely.
and which types of problems like that non-compliance problem shut out and
Yeah,
resolve. Yeah.
definitely. Definitely, if you are a Lean Six Sigma certified person, definitely among your peers, you will be able to differentiate yourself. Definitely.
Thank you, sir.
Okay. Yeah, Vasudevan Kantappan. Yeah, we will just share you. Which vertical you are in? Vasudevan, I think you are, I can see your this thing. So, which you are in manufacturing, or can you just see like which domain you are working and what product or service you are offering, and which function, whether it's quality or operation, you can just give the details. And again, I had shared you the link of our this thing, no? So there itself, in our website itself, we can see a lot of. I can also show you.
Hello. Yes, good evening, sir. Vasudevan here. Good evening, sir. Vasudevan here.
Yeah. Tell me.
Yeah, I'm into oil and gas projects, sir.
Oil and gas. Okay. So
I'm
oil production.
No. Oil and gas construction.
Oil and gas construction, right? Okay.
Yes.
Oil and gas
So I
construction.
was working. Yeah, I was working as a QAQC manager there in oil and gas project.
Okay.
QAQC manager.
So you can see here, in this our website, what they have given you the address. So you can see that there are case studies.
Yeah.
So you can see there.
So if you have any case related to oil gas construction, so that it will be identical for me to come for the courses, sir.
Yeah.
Related to oil and gas project, do you have any project?
Yeah, oil and gas, yeah.
Yeah, sample project, anything if you have. Yeah, please tell me, sir.
Yeah. Yeah, we'll just share, I think. I will just see. Construction infrastructure, I remember I have one. So oil and gas, I will just see, yeah.
Yeah.
They will share with you, yeah.
Because I didn't get your mail ID. Otherwise, I thought of requesting you, but in general chat I put that way.
Yeah, sure. So we have captured your mail ID, so we will share it with you. No issues.
Yeah, but so that I can check myself whether it suits my how they work.
Yeah, sure. Sure. Okay.
Thank you, sir.
Okay, thank you. Okay, then. Any questions? You can just ask me now. Otherwise, we can close. Thank you. Bye. See you. All the best in your career.